Beneath Adelaide right now, 3 giant steel machines are gearing up to consume 8 million tonnes of dirt and rock. This is the River Torrens to Darlington project, or T2D, and it is the largest road build in the history of South Australia, with a price tag of $15.4 billion. These machines are entering a zone of extreme water pressure and unstable clay, conditions that can destroy structures in seconds. If engineers misjudge the pressure by even a fraction, the road above could disappear. So how do they tunnel at this scale without the surface moving even a centimetre? To understand why we are going deep underground, we have to look at how this city grew over time. For a very long time, Adelaide has had a big problem that other major cities in Australia do not have to deal with. It is the only large city on the mainland that does not have a non-stop highway running through its middle. This means that for years, cars and big trucks have been stuck at red lights, moving very slowly through neighbourhoods and city traffic. Every day, more than 120,000 vehicles try to use these roads, and it has become a total mess. The plan to fix this started more than 20 years ago. The government decided to build a 78-kilometre long road called the North-South Corridor to connect the top and bottom of the city without any traffic lights. They finished most of it in stages, but the middle part, this 10.5-kilometre section from the River Torrens to Darlington, was the hardest to build because so many people live and work there. Engineers looked at building big bridges or deep trenches, but they realised that would mean tearing down too many homes and heritage sites. So they chose the most complex and expensive path, going underground. But how do you start a project this big when you have to dig under thousands of houses and businesses without causing a disaster? The answer lies in the most amazing pieces of equipment ever used in South Australia: the tunnel boring machines, or TBMs. These drills are giant moving factories that work 24 hours a day, 7 days a week. Each one is about 15 metres wide and 100 metres long. These titans are being built by a famous company in Germany called Knecht, and they are specifically designed just for the dirt in Adelaide. Why do they need special machines? Because the ground under Adelaide is mostly clay and soft soil, not hard rock. If you try to dig a hole in soft clay, it wants to cave in and fill up the hole immediately. To stop this, the TBMs use a special trick called earth pressure balance. At the very front of the machine is a giant spinning wheel called a cutter head. This wheel has sharp metal teeth and discs that grind away at the dirt, but as the dirt is cut, it stays inside a chamber at the front of the machine. The machine keeps this chamber full of dirt and pushes it hard against the ground in front of it. This pressure from the machine is exactly the same as the pressure from the earth above, which keeps the tunnel from collapsing while the machine moves forward. Inside the machine, it is a very busy place where up to 20 specialized workers are operating the controls. They have to monitor the pressure and the speed of the cutter head every second. As the dirt is ground up, it gets mixed with a special foam or water to make it soft like toothpaste. Then, a giant screw conveyor, which looks like a massive metal corkscrew, pulls that soft dirt out of the front chamber. It drops the dirt onto a long belt that carries it all the way out of the tunnel to a big shed on the surface. While the front of the machine is digging, the back of the machine is building the tunnel walls. This is done using a robotic arm called a segment erector. The machine picks up heavy pieces of concrete, called segments, and fits them together to make a perfect circle. Each circle is made of 10 segments, and each segment can weigh up to 12 tons. Once a full ring of segments is in place, the machine uses powerful hydraulic arms to push against that new ring. This push is what moves the whole 100-metre-long machine forward another few metres so it can keep digging. They do this over and over, moving about 8 to 10 metres every single day. To make sure they have enough concrete pieces to build the walls, the project has built its own massive factory at a place called Waterloo Corner. This factory is 285 metres long and will produce more than 55,000 concrete segments. They are using so much concrete that it could fill up 112 Olympic-sized swimming pools. Every segment is made perfectly to fit together so that no water can leak into the tunnel. But before the TBMs can start their journey, the engineers have to build a place for them to enter the ground, which they call a launch box. These are massive trenches that are deep enough to fit the giant machines. To keep the sides of these trenches from falling in, they use a technology called diaphragm walls, or D-walls. They use big machines to dig very thin, deep slots into the ground that are 35 to 45 meters deep. While they dig the slots, they fill them with a thick, heavy liquid called bentonite slurry. This liquid is like a heavy mud that pushes against the sides of the slot to keep them from collapsing. Once the slot is deep enough, they drop a giant cage made of steel into the slot and pour concrete into it. The concrete pushes the mud out, and when it gets hard, it forms a solid wall deep in the earth. These walls are strong enough to hold back the weight of the city while the TBM starts its work. One of the biggest challenges for the engineers is what to do with all the dirt they dig up. Tunneling for this project will create about 8 million tons of dirt, which is called spoil. They cannot just leave it in the street, so they have a plan. Trucks carry the dirt to a special site in a place called Gilman, where it can be used for other things. They also have to be very careful, because some of the dirt might have old chemicals in it from factories that were there a long time ago. They test the dirt constantly to make sure it is safe before they move it. Even after the main tunnels are built, there is still more work to do underground. They have to build small connecting tunnels between the two big ones every 120 meters. These are called cross passages, and they are there so that people can get out safely if there is an emergency. These smaller tunnels are dug with 2 mini TBMs that are about 4 meters wide. The whole tunnel system needs a lot of electricity to stay running. They built a special power station called the Tonsley Substation just to provide the energy for the machines and the lights. This power station has 2 giant transformers that make sure the lights never go out, and the big fans keep the air fresh inside the tunnel. They also use smart computers and sensors, called intelligent transport systems, to watch the cars. These computers can sense if there is an accident and immediately change the speed signs or close the lanes to keep everyone safe. But with such a massive project, we all know that it comes with some difficult trade-offs to consider. Wouldn't you agree? Building this superhighway is not just about machines and dirt, it is also about the people and the cost. The project is going to cost $15.4 billion, which is a huge amount of money that is being paid for by both the state and the federal governments. While it will save people 40 minutes of driving time and create 5,500 jobs every year, not everyone is happy. To make room for the road, the government had to buy more than 500 properties, which means many families and businesses had to move away from their old neighborhoods. People living near the construction sites also worry about the noise and the shaking from the big machines, though engineers say they are using sensors to make sure the vibration is kept very low. Even with these worries, the project is moving forward very quickly. The giant TBM parts are already arriving at the port.